Okay, here we have, I'm going to put in what is going to be the weakest or most reactive metal in not even an acid, but in water. And we'll see if it reacts. There, it's definitely reacting, and that's some sodium metal. And so, because if you think of this as a contest, sodium is definitely in last place. That is quite spectacular. Now that sodium is down and out of the competition, we're on to zinc. And this, I put some zinc in water, which is the same thing I did with the sodium. And you can see some bubbles, but those are just bubbles from the very beginning when I dumped it in. They don't continue, as you will see. So zinc is still in the competition because it will not react with water. And just to show you this is a clip about a minute later. The bubbles have stopped. Zinc's still in the competition, so now we're moving on to our weakest acid, which is actually very strong, hydrochloric. And it reacts big time. Zinc reacts with hydrochloric acid, and so it is out of the competition. Now that zinc is out of the competition, we're on to our next metal, copper. And this is some copper in water, and it clearly does not react. And so now we're going to move on to copper and hydrochloric acid. Okay, we're now going to put copper in the acid that did in the zinc, and we'll see how it holds up. There we go, copper and hydrochloric acid, and you can see there's a little bit of color change at the beginning, but that is just because the acid is reacting with the oxides and hydroxides on the outside because they were old pieces of copper, excuse me. But after that is done, as you can see, there is no more reaction whatsoever. Copper withstood hydrochloric acid, so now I'm putting it in nitric acid, which is an even more corrosive acid, and as you can see, it succumbs to the nitric acid. It is reacting, and it is forming copper nitrate and nitrogen dioxide gas. It's quite a cool reaction, and the end solution is a blue-green. You see that little piece of foil there? That's actually gold foil that I had put the gold foil in there before, and I didn't want to waste nitric acid, so I couldn't take it out, so I just left it in there. Copper has succumbed to the nitric acid, so now we're on to the next metal, gold. Now, it's pretty obvious gold won't react with water, but just to be scientific, I decided to put some gold foil in water and demonstrate that it doesn't react. And there you go, it's at the end of inoculating wire, and it doesn't react. And now, just to be scientific again, I'm going to put some gold foil into some hydrochloric acid. Kind of hard to see, but there is some gold foil in there. It's floating around, it's floating on the surface. There we go, I'm zooming in. Oops, the camera didn't focus, but there you go, you see gold. The gold did not succumb to the hydrochloric acid, so now we're trying the next strongest acid, nitric acid. And there you go, you see, zoomed up a little, there's some gold floating in nitric acid. And as you can see, there's absolutely no reaction whatsoever. So we're going to have to try something a little bit stronger. In this beaker, I have some nitric acid, and I'm about to pour in some hydrochloric acid. Nitric acid plus hydrochloric acid, in ratios of about 3 parts hydrochloric acid to 1 part nitric acid by volume, makes a acid mixture called aqua regia. It's aqua regia means royal water, and it's called royal water because it can actually react with gold. The reason it can react with gold, the mixture of nitric acid and hydrochloric acid, when neither nitric acid nor hydrochloric acid can react with it on their own, I will discuss in the gold video. But for the ruthenium video, let it just be said that even gold succumbs to the combined powers of nitric acid and hydrochloric acid. The yellow color, part of the yellow color you see is actually from some of the decomposition of the acid. When they're mixed, then they immediately start decomposing. However, in a little bit, I'm going to cut to the end. It takes about 5 minutes for the gold to completely react. It'll become much deeper yellow, and that'll be because of dissolved gold. Okay, I closed the garage door so you can see this better, and there's just a little tiny bit of gold left. It's almost all dissolved. And I'm going to skip to the end. This entire process took about 5 minutes. And you can see the deep yellow color of the solution is because of dissolved gold. Okay, now all of the gold has been reacted, not a trace remains, and this is now a solution of chlororic acid. And of course some nitric acid and hydrochloric acid that's unreacted. Now that the gold has come to the aqua regia, we're on to ruthenium. And just to be scientific, I decided to put ruthenium in water. And there you see, it's not reacting. Okay, now this is some concentrated hydrochloric acid. And there is the ruthenium. And this is probably pretty obvious, but it's not reacting. On to nitric acid. Okay, here's some nitric acid, and there's the ruthenium metal. And it's not reacting. Okay, this is nitric acid, and I'm about to add some hydrochloric acid, and then the resulting acid will be king of the acids, aqua regia. That dissolved gold. Let's see if it can dissolve, or react with, rather, ruthenium. So I'm going to wait a little bit of time just to make sure that the ruthenium is not reacting. And, yeah, the ruthenium is not reacting. I'd seen Nerd Rage's video with ruthenium, and he had apparently shown that ruthenium has kind of an Achilles heel. When you put it in bleach, it actually starts to react. I tried this, and this is a shot of the ruthenium in bleach, but as you can see, it didn't react at all. I'm not sure what I did wrong, if I didn't wait long enough, though I waited quite a bit of time, or what was wrong, but this just goes to show that science is sometimes unexpected.